On November 2nd, 2000, a mysterious user appeared on an online forum. His name was John Titor. He claimed to be a soldier from the year 2036, sent back in time to retrieve an old IBM computer needed to fix a technical problem in the future. Sounds strange, right? But here's the thing. He didn't just stop there. Titor posted dozens of messages describing future events in eerie detail. He spoke about civil conflicts in the United States, global tensions, and even hinted a breakthrough in technology. Some of his predictions seemed close to reality, others completely missed. But what really captured people's imagination wasn't whether his predictions came true. It was the possibility that he might actually have traveled through time. Thousands of people debated, was he real, a fraud, or had we just glimpsed a traveler from another century? Now, whether John Titor was genuine or not doesn't matter as much as the question he raised. A question humanity has asked for centuries. Is time travel actually possible? To explore this, let's first step back and see where the idea of time travel really began. Believe it or not, the idea of moving through time is much older than Einstein or science fiction movies. Ancient myths and legends often told stories of people who somehow skipped years in a single night. In Hindu mythology, King Raivata supposedly traveled to the heavens and returned to find hundreds of years had passed on earth. Fast forward to 19th century, when writer H.G. Wells published The Time Machine. This was the first story that gave people a clear mechanical way of imagining time travel, not as a miracle, but as something science might one day make possible. Since then, time travel has been a recurring theme in literature, movies, and culture. From Doctor Who to Interstellar, the fascinating remains the same. Can we break free from the straight line of time? And that's where science steps in. What once lived only in myths and stories started becoming a serious scientific question. In the early 20th century, a young patent clerk in Switzerland named Albert Einstein was about to completely change the way we understand time itself. Until then, time was thought of an absolute, like a ticking clock in the sky that moved forward at the same pace for everyone, everywhere. But Einstein dared to ask a bold question. What if time doesn't flow the same for all of us? His famous theory of relativity showed that space and time are woven together, like threads in the same cosmic fabric. And when that fabric bends, so does time. Here is the mind-blowing part. If you move very, very fast, close to the speed of light, time actually slows down for you compared to someone who is standing still. And this effect is called time dilation. And it's not just a theory, it's been proven. In fact, astronauts aboard the International Space Station are technically time travelers because they orbit Earth at incredible speed. Their clocks tick just a tiny bit slower than ours on Earth. The difference is tiny, fractions of a second, but it's real. Even more amazing, in 1971, scientists carried out the Hafele-Keating experiment. They flew atomic clocks around the world on commercial airplanes. When the clocks returned, they were ever so slightly behind the ones left on the ground. Time had literally moved differently for them. So does that mean we have already built a time machine? Not exactly. This kind of time travel only works forward. You can leap into the future by moving at extreme speeds or being near strong gravity. But you can't go back. Still, it raises a thrilling possibility. If technology advances far enough, could humans travel years, decades, or even centuries into the future, simply by riding the waves of relativity? If moving close to the speed of light can bend time, then physicists began asking, is there another way to travel through time? And that's where the idea of wormholes comes in. Picture the universe as a giant sheet of paper. If you want to go from one side of the sheet to the other, the normal way is to walk across it. But what if you could fold the paper in half and pokes holes right through. Suddenly, two distant points in space and time are connected by a shortcut. This is exactly what scientists mean by a wormhole, a tunnel in the fabric of space-time itself. Travel through one end and you might emerge not only light years away in space, but possibly years away in time. Sounds like science fiction, right? But here's the twist. Wormholes are allowed in instant situations. Mathematically, they could exist. The problem is keeping them open. A natural wormhole, if it is formed, would collapse instantly. To hold one open long enough for travel, scientists think you would need something exotic, like negative energy or exotic matter. Stuff we have never seen and don't even know if it can exist in usable amounts. But the theory is tantalizing. Imagine a tunnel that connects today to the year 3025, or even back to the dinosaurs. Wormholes are the one of the few scientific ideas that suggest time travel to both the past and future might be possible. Of course, there's a catch. Even if we build such a tunnel, stepping through would raise dangerous questions. What happens if you meet your past self? Could you change history or even erase your own existence? And that brings us to face with the strangest part of time travel, the paradoxes. Time travel sounds exciting, but it comes with the problems that twist logic itself. These are called paradoxes, strange contradictions that make scientists scratch their heads. The most famous one, the grandfather paradox. Imagine you travel back in time and accidentally stop your own grandfather from meeting your grandmother. That means you were never born. But if you were never born, how did you travel back in time to do it? A loop of logic that makes no sense. And then there is bootstrap paradox. Suppose a scientist in the future builds a time machine and gives Shakespeare a copy of Hamlet. Shakespeare publishes it as his own, and centuries later, the same play inspires the scientist to send back in time. But then, who actually wrote Hamlet? The idea exists in an endless loop, with no true beginning. Paradoxes shows us just how fragile the concept of traveling to the past really is. Because if time could be changed so easily, reality itself might fall apart. Some physicists suggest that nature has built-in rules to prevent these contradictions. According to the Novikov self-consistency principle, if you go back in time, events would always adjust in such a way that paradoxes never occur. In other words, you could visit the past, but you could never change it. Others argue that time travel to the past could create entirely new timelines, parallel universes where every choice spins off into a new reality. Kill your grandfather in one universe and you would still exist in another. The problem is, we simply don't know. Paradoxes remains one of the biggest challenges to the possibility of time travel. And yet, despite these puzzles, scientists have tried to test the limits of time itself, which bring us to real-world experiments and discoveries. We have talked about theories, paradoxes, and wormholes. But has science ever tested time travel? Surprisingly, yes. Back in 1971, scientists carried out a famous test called the field-keeping experiment. They took super precise atomic clocks, placed them aboard commercial airplanes, and flew them around the world. When the clocks returned and were combined with those left on the ground, the flying clocks were slightly behind, just as Einstein predicted, and they had literally experienced time differently. Astronauts on the International Space Stations also experience this effect every day. Traveling at nearly 28,000 kilometers per hour, their time runs just a little slower than ours on Earth. It's not much, only milliseconds, but it proves that time dilation is real. In a sense, astronauts are time travelers to the future. Even nature itself gives us hints. Black holes, those mysterious giants in the space, can bend time to so severely that, near their edges, time almost freezes from outside perspective. In theory, if you could orbit close to a black hole without being torn, you could jump far into the future while only a short time passes for you. And then there's a strange world of quantum mechanics. Experiments with tiny particles have shown bizarre behavior, like particles that seem to influence each other instantly across distances. Some scientists wonder, could this quantum weirdness someday reveal loopholes in time itself? So while no one has ever built a machine that lets us visit the dinosaurs or peek into the year 3000, experiments shows that time isn't fixed. It can stretch, bend, and even flow differently depending on the speed and gravity. Which leaves us the ultimate question. If we can move forward in time, is traveling backward ever going to be possible? And what might the future of time travel holds? So after all this, where does science really stand? The truth is, traveling into the future is not only possible, it's already happening. Astronauts in orbit, atomic clocks on airplanes, even the flow of time near massive objects like black holes, all prove that we can move forward in time, even if only in small steps. With advanced technologies like near light speed spaceships, humans might one day leap centuries ahead in just a single lifetime. But when it comes to the past, things get tricky. Wormholes, exotic matters, and parallel universes are fascinating ideas, but they remain beyond our reach. The paradoxes of changing history may mean that universe itself simply won't allow us to go back. Still, scientists never stop exploring. Every new discovery about gravity, quantum mechanics, or cosmic physics brings us closer to the understanding time's deepest secret. Who knows? Maybe in 100 years, time travel won't just be a dream of storytellers, but a tool for explorers. Until then, time travel remains the perfect mystery, a blend of science, imagination, and wonder. So next time you look at the stars, remember, out there in the universe, time is not fixed. It bends, it stretches, and maybe, just maybe, one day we will learn to ride its current, like travelers in a cosmic sea. Do you think time travel will ever be possible? Let me know your thoughts in the comment below, and don't forget to subscribe for more mind-bending science videos. Thank you.